In these Cirrus SR22Ts or TNs, there's built-in oxygen systems, and they can be a little frustrating if you don't know how to do the top-offs yourself. We found that shops around the country charge anywhere between like 150 and 450.
Yeah, Aspen was like 400 and you need to have it there.
The whole O2 thing can be very expensive and a little frustrating if your shop can't even get you in, or if you don't want to pay $400 and some for you to be topped off with O2. You bought the turbo or the turbo normalized engine for high altitude flying typically, so we're going to show you guys how we found both our Colorado setup and our Wisconsin setup a cascade system to top off your own oxygen. It's legal owner maintenance. It saves you a ton of time in the end and a bunch of money. So our setup is actually mounted on the other side of this wall. We have a cascade system that I'll show you back there. That way it keeps it clean on this side. We've got our valve. We're going to keep the valve off and we're going to hook up our hose. I'm going to put a link in the description of what this hose is. Every part that you buy needs to be considered oxygen safe or oxygen clean. And basically what that means is if there's any contaminants or any oil that's in the line, that can be very explosive because pure oxygen is extremely explosive. So make sure that every part that you use is considered oxygen clean or oxygen safe. So we're going to hook this up to the plane. I keep on here a 11 millimeter or 7/16 wrench. That way it's ready to go. So this is the same size that you can use to remove the cap, the safety cap. This adapter is for Cirruses, so it goes to a 3/8 international pipe thread, IPS, I believe it's called. And this is a female, typically comes on the extension hose, and then the adapter comes with a male. So I'll put all these parts in the description. So if you have a Cirrus or many Cessnas also use this adapter. I think there's other manufacturers that use it as well, but I'm not positive on all the manufacturers, but know for sure Cessna and Cirrus because I've hooked them both up and they work perfectly. So a quarter turn counterclockwise with the number 1 or number 2 Phillips. That exposes this safety nut cap. So the first step is to pull off this cap. You can use either a 7/16 or an 11 millimeter. So that's the safety cap. And then there's an adapter. This adapter goes onto the end of the hose, and it's also a 7/16 or 11 millimeter. And you're going to just snug that up with a few inch-pounds of torque. That's it. We currently have 800 PSI, and we're going to charge the system up to 2000 PSI. So when you install this, you just make sure that there's no tension on the hose or the adapter. And that way it can seat itself perfectly straight inside the flared fitting of the aircraft. Your next step is, if you have a valve like mine, you open this valve 100%. Now let's go on the other side of the wall. I'll show you the cascade system and explain how that all works. So this is what I believe it's considered a cascade system. In short, the more tanks you have, the better in a couple different ways. Not only can you get more fills out of them when you have more tanks, but also you can utilize each tank more. And I'll explain that in a second. Basically, what I do is I write on here with a crayon how many PSI is in these tanks. So 2500, 2500, 2500, 2250, and then 1550. And it's really important to cascade in one direction or the other. So I choose to cascade in this direction. What that means is, for the first 1,550 pounds, we're going to utilize this tank. Then for the next, from 1,550, or what will become probably 1,450 roughly, up to 2,000, we're going to utilize this tank. And the reason we do that is right now, if I was to use this tank to fill up the airplane, and then again I used it a week from now to fill it up again, this tank would drop to underneath 2,000 psi within a couple fills, and then you will not be able to top off the airplane after that. If you cascade, you can basically take the PSI of each tank and utilize it effectively. So you can bring this tank all the way down to 200 PSI or 100 PSI as long as it's more than what's in the airplane. So it all makes sense as we do this, as we cascade. So because we're gonna pull from this tank first, I'm gonna first open up this valve that feeds our hangar, right? Because this is I share this oxygen with our neighbor here. So this is how they fill up their plane, and this is how we fill up ours. Same exact thing, we're both using the cascade system. This is your pressure regulator. So this gauge tells you how much pressure is actually in this tank. This gauge, you adjust how much pressure is going to go into the airplane. So we're going to turn on just this valve. Okay, we have this one turned on, so right now it's all the way opened up. Open up this tank. All right, and you can see on this gauge that we are at 1,500 pounds. All right, I'm going to crack this open, confirm that there's nothing running through it. There's nothing running through it, okay? We're going to take this, we're going to turn this in. When you turn it clockwise in, it's kind of counterintuitive. That's what actually increases the pressure going out of this valve assembly. So this is like a standard pressure regulator for a welder, so they're very familiar with this. But as aviators, we maybe never used one of these before, so it is counterintuitive. Clockwise, as you start to feel that tension, actually increases the pressure. And right now what we're doing is we're telling this gauge, okay, how much of this 1,500 PSI do we want to send through? So I like to be very conservative. So what I'm going to do is set this only to 1,000 PSI. This is a flow meter. So this, in my opinion, is very smart to have. It prevents you from filling your oxygen bottle in your plane too quickly. As you transfer oxygen, the lines all heat up. As they heat up, the air expands. So you do not want to overheat your O2 lines because then you can overpressurize your tank. So I bought this valve, this flow regulator, I should call it, and it regulates 200 PSI per minute of flow. So we know that by me opening this up 100%, I'm not going to be feeding any more than 200 PSI per minute. So I'm opening it up, you can hear it running through. You're going to see this slowly drop because our pressure from here is slowly dropping and it's filling up our aircraft. This should stay at roughly exactly 1,000 PSI because we told the valve to send out 1,000 PSI. I just went over to the other side and I confirmed that in the aircraft is now 1,000 PSI. So on that gauge, it now shows 1,000 PSI. So we know everything is running and flowing smoothly, and it stopped because you can actually audibly hear when the flow stops. It'll stop at this will stay at 1,000. This is coming down in pressure, right? It started at roughly 1,550 or 1,525. It's now down to 1,410, 1,420, something like that. So we are transferring that pressure over. So now, and this is still open, right? This is closed. This is your bleed air. This is still open. Everything's open on the other side. So now we're going to take this and we're going to turn this clockwise to bring the pressure all the way up to what the tank can handle. So basically I went like this, I turned it all the way, and then I stopped turning. So as soon as this maxed out the pressure of the tank, I stopped turning so we don't hurt the diaphragm. So we are telling it, okay, that's 1,000, 11, 12, 13. We're telling it 1,350 can go into the aircraft at a maximum flow of 200 additional PSI per minute. We don't hear any sound anymore of airflow coming through the lines. and it's maxed itself out. Or I should say these two needles are now reading the same amount. So we have 1350 or so, and we have 1300. So we know we're basically maxed out because there's just a 50-pound discrepancy between the two. So what we're going to do is shut this. Shut this. We are done using this tank, and we know that this tank is at 1350, so we're going to write that down so we know for future fills that this tank is good up to 1350, which after it fills, the airplane will probably come down to about 1250, 1150, something of that, roughly of that PSI. Now our next tank, 2250, has to take us up to 2000. I think it can do it. So this is closed, this is open. You only want one tank open at a time. This is a cascade system. Air can backflow from one tank to another. So these should all be closed and just the one open that we want to pull air from, because as you can see, there's no one-way valves installed in these lines. This is purely connected. We are now charged 2250 all the way up to the connectors of each of these tanks, or all the way up to the valves of each tank. So now we can see on this gauge our true poundage. So we have 2,250. So we know that we wrote it down correctly, and it's showing 2,250. It's actually showing 2,300 strong, 320. So that's great. We know that we probably have enough to bring up our airplane up to our 2,000 PSI. So this is closed. We're going to bring this up to 2,000. Right there. We're going to slowly open our flow meter. Bring this back to 2,000. And we're slowly feeding, right, into the airplane up to our 2,000. So we're going to watch our tank go from, say, 2,320 down to roughly 2,100 or 2,200 in order to get our, I think it's an 80 cubic foot in the Cirrus, or it's 88 cubic feet, one of the two, our built-in oxygen tank filled up to 2,000 PSI. So we walked over to my hangar and confirmed the gauge on there now reads 2,000. It took about 5 minutes or so because of the flow. You want to control that flow so that you're not overheating any of your lines, which is overheating the oxygen going into the plane, which is dangerous. So we kept everything nice and cool. We did a nice slow flow. So now that we're at 2,000, this tank, so this tank here, is brought down to 2,100. So it started off at, say, roughly 2,300. So we sucked out 200 PSI out of this tank. So we're going to take this crayon and write on there 2,100, so we know for next time. All right, then the next step is we're going to take this valve and shut it down so we can separate the airplane. Now the airplane is separated completely from this system, so we don't have to worry about it backfeeding this system. We can take this valve and we can shut it. Okay, we can take this valve and release it, or relieve the membrane. This is not going to move yet, and you'll see why. Right now we're trapping air, so we've got air trapped from here to here at 2,000 PSI. Actually, from here to here, it's trapped at 2,100. From here to here, it's trapped at 2,000. Should make sense by now. This is open all the way. Okay, or bleed air. Open up the bleed air. We're right now draining this. We're draining this entire system down. In order to get this to drop down, we open up our our valve, and you can see now that this is dropping down because it's taking that 2100 PSI and it's letting it run through. It's a good habit to discharge the system every time you use it, even though it does waste some of your O2. So now I can close the bleed air, I can close this valve, and everything is then returned to a safe condition for storage. Now we're going to go on the other side of the wall, we're going to close this valve, disconnect the hose, and we're done. So now on this side, we shut off the valve. It's redundancy, but you want redundancy for safety. So now, again, this is completely secluded from what used to be the pressurized system. So now we come back over to the airplane and we confirm 2000 PSI is on the gauge, so we properly filled up the tank. This hose, or this line, is now shut down, so we can disconnect this. There is a one-way valve on the airplane, so you're gonna hear a bunch of air come out. That's normal. It's just the air from the hose. So the shorter the hose, the less you're gonna waste every time you do this. Then you put on your plug or your cap. Turn it counterclockwise just to get alignment. Once you're aligned, tighten her up. Put maybe a few inch-pounds of torque on that just to make sure it doesn't loosen up during flight. And then let's see if I can do this one-handed here. You take your Phillips, quarter turn, and you're done. That's it. Let's talk about real briefly the different types of masks or cannulas. So this is actually a dog hood. We're going to do a dedicated dog oxygen video, so I'm not going to go into depth on this, but this is made by Four Paws Aviation. Highly recommend. We've had our 3 dogs in these, no issues. These are the A5 flow meters that come from Precise Flight, that come with any Cirrus with built-in oxygen. Comes with these A5s. These are okay units, but we have found that the units by Mountain High are a little bit nicer and more robust. That's what we have on the dog hoods. This is a Mountain High unit, and so I can put links in the description to this flow meter. And basically, in short, it's just got higher quality parts, so the valve doesn't turn so easily during flight. It also is a little bit easier to read, and it just seems to be more robust with a better connection on both ends. And it's in line instead of these guys turn 90 degrees. So when they're hanging like this from the ceiling, they literally hang at an angle, whereas this hangs nice and straight. So I do recommend these. I'll put a link in the description. Here is your standard cannula, and I don't know of a single person that enjoys wearing this thing. Basically, it feels like you're in a hospital. These things go over your ears. This is directly into your nose. You can run this, but we'll show you on the airplane something that we found is much more comfortable and easier to set up on your face. This is the mask that comes with all Cirruses with built-in oxygen. So actually, this comes with the A5s, and so does this. Again, actually, you know what? I take that back. I don't know if this comes with. We got this from Precise Flight in some other parts that we bought, so I'm not sure if this comes with OEM. But in short, not very comfortable. Don't recommend it. Here is your flight levels mask with the built-in microphone. So this we do use in the flight levels, and you have to, but we use it right now. We're actually sending these out to be serviced, and our Mountain High regulators are what go on these units. So I do recommend these. Obviously, in the flight levels, this is the only legal route and the only safe route. So now let's hop in the airplane. I'm going to show you our actual setup for everything up to 18,000 feet. To me, that is definitely the most comfortable. So we went with a company called Mountain High Oxygen. I'll put a link in the description. They were really good to work with, and they walked me through exactly what I needed for this plan, and you can do the same thing with them. I'm going to simplify it though for you by putting links. If you have a Cirrus, I'll put links that you can utilize of what you can buy from Mountain High to make this setup work. But basically what we have is 2 pulse ox units, and they greatly reduce your consumption of oxygen. So what you're going to do is you've got, I forget what this fitting is called, but this is the OEM stainless steel fitting that connects to your OEM oxygen system. Okay. Then it does have this regulator. So this regulator is designed specifically for the precise flight O2 system built into the airplane at that flow rate and pressure that it needs. So make sure you get this exact unit from Mountain High. And then I have it going to a splitter. And then that splitter feeds 2 units, and they're each called an O2D2. O2D2. Those units are electronic, they're battery powered, they're right here. You can turn it from off, on, 5,000, 10,000, flight level 1, 2, and 3. Basically, flight level 1, 2, and 3 increases, 1, 2, 3, and 4. So there's 4 different flight levels. So if we're flying at, say, 13,000, 14,000 feet, we'll be on flight level 1. If we're up above that, up to about 18,000, we'll be on flight level 2 or 3, and that increases the amount of oxygen that you're getting. We both wear pulse oximeters, and those, in case those are faulty, we do have then 2 pulse ox in the plane. What that does is, instead of utilizing the OEM oxygen system as constant flow, it instead is an electronic valve that opens and closes only when you breathe in. So here's my headset, and my wife has the exact same one. Okay, so basically, when you have your headset on, you can just loosen this up and swing this boom. This is an O2 boom, also made by Mountain High. So you just have a little adhesive aluminum ball that sticks right on your headset, and it stays on there for good. And then you can swing this boom down. And honestly, when you have this adjusted properly, this slides in and out, and then it also rotates. Once that is adjusted properly, you don't even notice that it's there. It's fantastic. And then when you're done with your oxygen, you just loosen up the set screw and put it up like that. So we love this system. It's been working great for us. It saves a ton of oxygen, and it reduces the chance of you drying out your nasal cavities. If you run these as constant flow, how it's designed in the OEM system, you're wasting so much O2, because whenever you're breathing out or not breathing at all, that O2 is just being evaporated, it's just being wasted. This only triggers oxygen when it senses you breathing in through your nose. So as long as you're not a mouth breather, there is 0 downside to these O2D2 units. And that is the electronic valve that automatically when you breathe in, and then it stops the flow as soon as you start breathing out, or if you're not breathing at all. The reason we have 2 is if we've got 2 passengers in the rear, instead of wasting oxygen, I like to have them on the O2D2 as well. But 90% of the time, Linnea and I are flying around alone. By having the second O2D2, it's redundancy. It's an additional safety factor. We also have extra AA batteries down here in case one or both of them runs out of battery. So highly recommend the system. You should love it if you fly your Cirrus up above 12,500 feet often. I'd highly recommend this versus constant flow. Constant flow oxygen tends to make people hate the oxygen system, whereas this system, frankly, we love being on this because we feel great when we get to our destination, and along the way, we don't even know that it's there.
We're up here at 14,000, and we want to show you the boom cannulas in action and also the O2D2 in action. What do you think about the boom cannula? Do you
Yeah,
like it?
I like them. I like them more than the ones that are like a mustache and then they go over your ears. I don't like the mustache.
Yeah, I don't like
look.
the mustache ones either. Yeah, these tend to be very comfortable, and then when you're done using it, like we showed earlier, you just swing it up. So it's really convenient to take it on and off. And once you have it adjusted in and out and the angle up in your nose, it's super comfortable. So let's show them the O2D2. So it's a little crammed in here, but you can see our main and then our backup, right? So we have this for passengers and then also for our own backup with this legal splitter. And again, mountain high oxygen can hook you up with all of these parts, no problem. You just got to talk to them about it. Let's go into detail more about this right here. So basically, let me see if I can see this. Okay, N, if I understand N correctly, that's like a neutral setting. And there's instructions that explain this much better. There we go. But N basically is going to give you a flow of oxygen no matter what altitude you're at. When I say flow, I mean a burst of oxygen only when you breathe in. So I just breathed in, I heard it, and I could feel a burst of oxygen. And then I breathed out, and it stopped the flow. That way you're not wasting oxygen. Then D5, basically that's anything above 5,000 feet, it's going to activate. D10, anything above 10,000 feet, it's going to activate. So it has a built-in altimeter in these units. We're at 14,000, so obviously that's staying activated. Flight level 1, 2, 3, and 4. So when we're high up, we're like on flight level 2 or 3 or 4. When we're down lower at, say, 12,000 feet or so, you can be at flight level 1. Basically, this is just adjusting the flow. So I want a little bit more flow, so I'm going to go to flight level 2. And then I can monitor my O2. Right now, I'm at 95%. So if I want to increase that, one, I got to stop talking, right? Because when you're talking, you're actually like mouth breathing a little bit. When you stop talking, you're breathing through your nose, and then your O2 levels go up. So typically, if I'm not talking up here, my O2 levels are, say, 97 through 99, something like that, at, say, 14 or 17,000. So I'll turn this up while I'm talking, just to give a little bit more of a burst while I breathe in. So now I could hear and feel the difference. That burst like almost doubled in length. Can you feel that?
Yeah.
So the only downside to that is that you're going to go through your oxygen a little faster. So here's our oxygen levels. So we're at 1670 right now. So we have plenty. If it was only Lene and I on this, we could run this at flight level 4, no problem, just to give ourselves the most oxygen possible when we breathe in. But because we have the dogs on it, the dogs just suck up a ton of O2 because they're on constant flow and there's no way to prevent that. We're going to go into this a lot more with the dog video, but basically these are designed to run at 60%. So if you're at 14,000 feet, you should be running these at, say, 8,000 or 9,000 feet. That's at least what the manufacturer of the hood, Four Paws Aviation, states in their documentation. But we want our dogs to just have that much extra, so we give them like 90% of the altitude rating. You can do whatever you want above 60. It's not going to harm them. The reason we're okay with running them so high is because we've got oxygen now in stock at both Colorado and Waukesha, and we can top off for so cheap that we got the luxury of just dumping the O2 into the doggy hoods. So, like I said, we'll have a dedicated video for that, but we just wanted to give you a little in-action representation of these units, and we've been very pleased with them. We are not sponsored by Mountain High at all, so this is all just very genuine and just honest feedback, and we've been using the system for maybe about 3 years now, and not a single fault. I actually think that those are the original batteries from 3 years ago in the O2D2, and we travel a lot with that. Almost every single flight we are on O2. But basically, in a nutshell, when you're flying over 12,500, as you know, you need to be on O2. The whole reason you bought a T or a TN aircraft is to be high altitude for catching winds, clearing weather. And today we're flying westbound, so we're not, up in the flight levels. that's when we're gonna have a mask on, and we'll probably be showing you that later in the video or in another video where we got full face mask on. But that's for flight level 180 up to flight level 250, which this aircraft is certified to fly in. So hopefully that helps.
We're over here in the Colorado hangar, and I wanted to show you guys a different option. This is a cart option. So on a cart you can put 2 tanks, which is pretty convenient for making it mobile. So you can transport it from one person's hangar to another on the field. Or so you can even roll it around the larger hangar. This is a shared hangar, so it works out really nicely to top off that 185 as well. So any more than 2 tanks, and you really don't want to put onto a cart. This is heavy enough, but 2 tanks gets you several months or a couple of years of usage for at least the buddy that I share it with here in Colorado. So if you do a tank system on a cart, it's kind of nice to have. I've got a lanyard with a number 2 screwdriver, Phillips screwdriver, a 7/16 wrench, and then a crayon. That way you have everything you need for the task at hand. So if you end up using a cart system with 2 tanks, a suggestion is to put a ratchet strap around them. A lot of guys will move these around with just these cheap chains, and it's not a secure way to move this sucker around, and it could be very dangerous if they topple over. So ratchet strap it, make it nice and solid. You'll have a pretty successful cart setup. It's just like the 5 tank system, but you're just cascading 2. So you just need 1 hose, 1 splitter, and then your regulator and your flow control. So this is very similar to the other setup, but the hoses are a little bit shorter, and we just have obviously 2 tanks instead of 5. So when you cascade these, this one is the main tank, so that's why it's already down to 350 psi, and then here's our secondary tank at 2000 psi. So after watching this, you know that basically this system can only get an airplane that takes 2000 psi up to about 1800 psi. So this system is going to be limited, whereas that 5 tank system can take you several months or several years usage beyond the 2 tanks. But at least now what we can do is swap out this tank. Once this tank hits like 200 or 150, we'll swap this out for a new one, and then we'll start pulling from this guy and then from this one. That way we can get back to our 2000 psi. But for the next several months, this system right here will still get us to about 1800 psi, then say 1600 psi, so it's enough for our missions. So as you know, I'm not an MP, I'm not an IA, so please do not take this as actual instruction. This is just what I've found works best for me in my situation with my aircraft. And so hopefully you can have some takeaways on something that will benefit you in your situation. If you haven't already, please subscribe to our channel if you like what you see, and hit the like button. That helps big time with the algorithm. We'll see you on the next one.